Bismillahir Rahmanir Rahim. Starting in the name of Allah, the Beneficent, the Merciful. Assalamu alaikum, everyone. My name is Nouman Qureshi, and I'm here to give the presentation of data structures and algorithm. And my group members are Adnan Bashir, Nouman Qureshi, which is myself, and Nouman Waseem. And the topic of our presentation is to perform deletion in a singly, doubly linked list. What is linked list? A linked list is a linear collection of data elements called nodes. So in linked list, elements are stored dynamically and the data in linked list are linked with pointers. In the diagram, you can see that all the data are stored in nodes. What is node? Node has two fields, one for the data and other for pointing to the next node. So in the diagram, you can see that each node has the address of the next node except of the last one because there is no next node. So the address will be null. Importance of linked list. A linked list is composed of nodes which are connected with each other using pointers, so it makes the program to be accessible more conveniently. The reason why linked list is important is because they are dynamically data structures which is resizable at runtime. Like you can change it at any time. Importance of linked list, like by comparing linked list with arrays, linked list is more efficient. All right, types of linked list. There are two types of linked list: singly linked list and doubly linked list. Singly linked list, it contains node with a single pointer pointing to the next node in sequence. As you see in the diagram, singly linked list has two fields, one for the data and second is for the address of the next node. Doubly linked list, it contains two pointers, one pointing to previous node and other providing to next node in sequence. So in the diagram you see that doubly linked list has two pointer fields and one data field. So it means that we can access the previous node. Doubly linked list contains three fields. First field contains the address of previous node and the last field contains the address of the next node and middle field holds data. Alright, basic operation on single linked list. We can perform insertion, deletion, searching, traversal, reversal, concatenation, and splitting. But here we will discuss only deletion. So deletion of item involves search for item in the list. If available, make its previous node point to its next node. So what we just have to do, we can search the item we want to delete. So we will just change the address of its previous node and point to its next node. Now here are the steps. So here step 1, find the previous node of the node to be deleted. Like if we want to delete 20, so we have to find its previous node. So in that case we have 50. Now on second step, change the next of the previous node. So we just have to change the next node of 50 and point it towards the next node of 20. Now on step 3, free memory for the node to be deleted. So we just have to free the memory of the node which is going to be deleted. Now step 1, creating a class node. So first we are creating a class with the name of node, then we are adding data members to class. Data variable will hold an integer value and then we are creating a pointer with the name of next with the type of node. Then we are creating constructor of a class node. Initially we will assign data variable to 0 and next pointer to null. And the second last step, we are dynamically deleting next pointer. All right, step number two, creating a class linked list. So we are creating a class linked list, and inside the class, we are creating two pointer variables with type node and constructor to assign head equal to null. Step number three, inserting node and assigning values. So in this step, we are inserting nodes using function with one parameter, which will get integer value from main function. Then we use if statement to check if head is pointing to null or some value. If the condition is true, then we are pointing head to the data receiving through function. In else part, we are creating pointer variables with the name temp of type node. Sorry, yes. So in else part, we are creating pointer variable with the name temp of type node, and then we are assigning to value of head to temp, which means head will point to the first node. After that, we are using while loop to check the address pointing to the next node. If condition is true, temp will store the address of next node. If condition is false, while will be stopped and point the next pointer to the value of next value of the node. Step number four, deleting and displaying nodes. So in this step, we are deleting a node from the linked list and then displaying the linked list using functions. In delete function, we use the structure, then we use the temp pointer to delete a node. We assign head pointer to the temp and then assigning address of next node in the head. So node pointed by the temp will be skipped in the linked list, and we manually free the temp from the memory. And in display function, we again created a temp pointer variable and pointed it to the head used while loop, which will check that head is not pointed to null. If condition is true, it will display data in a node and then point to the next address. Main function. In main function, we create a default constructor of class linked list and create it object L1. Then through that object, we call insert node function three times with three different values. As a result, it will create three nodes, then we simply display linked list before and after deleting a node. Now you will see the output of our code. Like before deleting node, we have values 50, 20, and 110. But after deleting the node, we have value 20 and 110. Thank you.